Hey guys, good morning. It's Mr. Slosson. I don't know where I am today. Maybe I'm sick. Maybe, like I said, I won the lottery and I'm down in Mexico shopping for a villa. But I did put together this little lesson for you. It's about the number that might be like the second or third most important number in the whole universe. When and if you meet up with the aliens, they will know this number. All right, guys, if you're in my class, this is worth 10 points. Use a pencil. Don't forget to write your name at the top. You can write out the definition of a square, or you could just draw me a little picture and show that all four sides are congruent and there are four right angles, and that will suffice. That's a square. Let's do the diagonal. I've got one over here. Let's just say that's the diagonal. Oh, we could do that, diagonal. And the hypotenuse, let's just draw a triangle and label that with the hypotenuse. And life is good, and write out the Pythagorean Theorem. Pythagorean Theorem, say it twice like a song. A squared plus B squared equals C squared. And that's what we're going to spend our time on today. We're going to deal with this pesky little thing called the diagonal of a square. Really useful information. Let's get going. The basic assignment is that we're going to draw three squares. We're going to measure the diagonal of each square, and then we're going to come to some conclusion about a constant number that will define the diagonal. Easy peasy. All righty, we drew our three squares of 5, 10, and 15 centimeters. Just used up the whole paper. I did mine in red. You can do yours in pencil. Or if the sub's got a colored pencil for you, you can do that too. So we've drawn the squares. Next, we'll draw in the diagonals. I didn't show you this earlier. I went ahead and put in a 3 centimeter square so I could use it as an example on the chart. You don't need to do that. You can do it if you want, just whatever. So once you've drawn all your squares, go ahead and measure your diagonals. So I did the first one. 3 turned out to be 4.2, and then you're going to measure the 5, and that'll be 7, and so on. Just keep labeling on there, and then you'll go fill out the chart, which I already started for you, so this shouldn't be too hard with a little help from the sub. I'll put that down, and we'll take a quick look. So just fill in this chart for each of the measurements you made and do the calculations as indicated. I'll catch up with you when that's all done. Turn the video off for now. When we finish drawing our squares, putting in the diagonals and measuring, and notice how all the corners connect. Now, that's a different lesson. We'll talk about proportions. We've got all these squares. We measured the diagonals, and we entered them on the table. And what we should have found is that if you take the side and multiply it by 1.4, you'll come pretty darn close to the diagonal of the square. You don't have to do all that figuring. Let's go back and just check out the Pythagorean Theorem one more time so we know why that's true. And by golly, I think we'll almost be done. So let's just take the example of we had a square with a side of 1. We start with 1 and we square it and add the square, which is 1 plus 1 equals 2. And then we find the square root of 2, which is the hypotenuse of the triangle, and that comes out to be 1.4, and that is the magical number. If you draw a square and write 1.4, you can begin your communication with the aliens right there on the spot. Hey, I'm sorry I was gone today. You guys have a great day. I really miss you. Oops, I forgot. There's a 4th page of work. Easy peasy. You can do all this. Find the area, find the perimeter. When you get to that big one, I gave you a hint. Start by finding the square root of that number, and life will be good. Hey, thanks for watching. I hope things went well with the sub today. Be nice. Remember, nobody ever got fired because they couldn't factor quadratics.